The AMD Radeon RX 9070 series consists of two members, the 97XT and the plain model. According now to AMD, it sits between the RX 7900 XT and XTX and RX 7900 GRE lines. The RX 9070 models have up to 64 CUs following the RDNA 4 architecture, and their GPUs consist of 53.9 billion transistors. The new GPUs are suitable for QHD and 4K gaming. The specs of both 9070 cards look similar, with the fundamental differences being on the CU units and the TDP. So the 97XT has 64 CUs and 304 watt TDP, while the 9070 has 56 CUs and 220 watt TDP. The 97 series utilizes the RDNA 4 architecture, which includes updated ray tracing and AI accelerators. Combined now with the 16 GB of video RAM, these accelerators offer strong gaming performance. To improve ray tracing performance, AMD doubled the ray intersection rate. The ray intersection rate is the speed at which a system calculates how many rays intersect with objects in a 3D scene during ray tracing. AMD also used two ray accelerators per CU to handle all required calculations quickly and efficiently. According to AMD, the updated ray tracing engine doubles the performance for both ray box and ray triangle testing compared to RDNA 3. Moreover, the ray tracing engine uses 128 kilobytes of shared memory, which might look small, but it is okay for this operation. AMD moved to BVH8, a type of bounding volume hierarchy. BVH used in ray tracing. It organizes objects in a scene onto 8 node groups for faster ray intersection tests, improving performance by reducing the number of calculations needed to find collisions or intersections. Lastly, to improve ray tracing performance, AMD introduced oriented bounding boxes to reduce or eliminate false positives in ray triangle and ray box intersections, and a dedicated ray transform block to help with transformation. A dedicated ray transform block is specialized hardware and GPUs designed to accelerate the transformation and manipulation of rays during ray tracing. It handles tasks like ray object intersection calculations more efficiently, improving overall ray tracing performance. We shouldn't forget AMD's new software technologies like FSR4, an upscaling technology that transforms low-resolution frames into higher fidelity ones, increasing performance. The FSR4 upscaling algorithm now uses an advanced AI model which exploits the RDNA AI accelerator for improved performance. No, we don't have fake frames here, since for the moment at least MFG is not supported, but there is only the plain good frame generation that we know, one real frame for one AI frame. And with that said, let's take a look now at the review, because I want to show you some stuff. So guys, this is the review on hwbusters.com. Please go and read some of it, if not all. It took me ages to complete this review. Let's take a look now at part analysis. So here are the main parts that this card has: the fan assembly, the heatsink, the main PCB and the back plate. The heatsink is large. I believe it can easily handle the TDP of this card. AMD says that it's 220 watt, but in reality it's 250 watt. And the GPU, on the back of the GPU, main capacitors for improving the transient response, actually helping in transient loads. So here is the part analysis in just one photo. A VDDC faces here and here, VSOC and VSOC here, MVDD and VDDCI here. We also have the two main PWM controllers here and here. there is an MCU, a Nuvoton MCU on this board, and here we have 3 buck converters which generate some voltages used by minor circuits on the PCB. RAM provided by Hynix, the Navi 48 GPU. All DRMOS are by MPS, MP87661, it's their type. Some details, some more details. We can see here some close looks at the PCI Express headers. Yes, AMD doesn't use 12 plus 4 pin. They remain on the 6 plus 2 PCI Express headers, which according to many it's the way to go. It's safer. Till we find out what is going on there with NVIDIA's cards, I don't know, some close photos of them and of the PCB. What I noticed on the real side of this card is that many capacitors are missing, guys. Many capacitors are missing. Look, all these empty spots should be filled with capacitors. But they are nowhere, these capacitors. Seriously, I don't know how the performance would be with all these capacitors in place, and I'm not sure how much more the price, the production cost would be with these capacitors, but I can't help but wonder why all these capacitors are missing from there, and how come the card works properly with all these caps missing. It looks crazy to me, I don't know. Basically, I think there's only the back side. Yeah, only these 2. 3 actually. 1, 2, 3 capacitors. Yeah, okay. Relative performance. Raster. I made the comparison with the RTX 5070 because the Radeon 9070 is supposed to go against the 5070. In raster, the performance boost is enormous, as you can see, almost 11%, and AMD card has the lead in performance per watt, almost 6% overall. Let's go now to raster and DLSS. Minor improvement there, mostly at UHD because I suspect of the larger RAM. Yeah, performance per watt is not that high as is in the 5070, which 5070 is an RTX 4070 Super with increased power consumption. Relative performance with ray tracing enabled. 12% better with ray tracing enabled. This is something, guys. Finally we see AMD kicking back in ray tracing. And performance per watt is also improved 4.7%. Ray tracing and DLSS or FSR enabled. Small difference there, but as you can see, Full HD, it loses. QHD, it takes back. UHD, it wins big time. So the average is 1.9%. In performance per watt though, because it loses heavily at Full HD, the average is minus 6.3%. But if you play all games at UHD, you will see good improvement here. Frame generation. The titles I tried, 2 weren't compatible with AMD's frame generation, with the FSR frame generation, so it's only Alan Wake 2, Cyberpunk, Indiana Jones, and Ratchet and Clank Rift Apart. The performance is vastly improved. I suspect mostly because of the more RAM. Most likely. So, average 13.36% performance improvement. Performance per watt, not that large, but we still have an improvement there, 2.5%. Rendering performance. DaVinci Resolve, as you can see, the 5070 has a huge lead here, almost 71 seconds faster. I cannot explain that. At H265, equal performance between the 5070 and the 9070, that is something at least, and Blender and V-Ray benchmarks require CUDA, so they are incompatible with AMD's GPUs. Operating temperatures, let's take a look here. Idle, relatively low idle temperature. AMD also has the hotspot. Multimedia, not bad. Rendering, the standard temperature is low, but the hotspot is way higher. It's about 18 degrees higher. Still, it's not that hot compared to other AMD GPUs that I tried in the past. Gaming without ray tracing, the standard temperature, as you can see, is very low, but the hotspot is higher than that. Still, guys, the hotspot temperature is way lower than the limit. With ray tracing enabled, 56 degrees Celsius, and hotspot 77, and Fairmark 58, very low for Fairmark. Okay, hotspot is higher, but still, it's low compared to about similar spec cards. 3D Mark Speedway, again, low, and the difference 20 degrees Celsius between the normal and hotspot temperature. And let's go now to operating noise. Okay, at full speed the fans are noisy, but who will run the fans at full speed? No way you will see that. 75% still noisy, 50% noisy again. But the fans are automatically controlled, thermally controlled, so there is no need for you to mess with the fan speed profile of this card. Idle, 6 decibels, it has, with 6 decibels, 6 decibel is the noise floor that I have. I cannot say 0 because I cannot take a reading below 6 decibels, so I use the noise floor of my Hemi anechoic chamber, which is the proper way to measure. I cannot say that, hey, it's 0 decibels. I don't know that because I cannot go down to 0 decibels. I can go down to 6 decibels. So I'm telling you that this is the lowest that I have measured. Multimedia, 6 decibels, meaning that the fan is stop. The fans don't operate. Rendering, 22.3 decibels. Okay, it's not among the quietest GPUs, but not among the noisiest either. Gaming with RTX off, 1% high fan speed, 20.6. It's very low, guys, for gaming. RTX on with 3D Mark Speedway, it's actually lower. With RTX on, it's actually lower, 18.2 decibels. And let's take a look at VSync. With VSync, it's very low, 10.2. Okay, that's very low. Fairmark, 99.8 decibels. That's very low for Fairmark. I'm surprised here. That's a positive surprise, of course. Let's look now at some frequency plots. In most of them, the peak is at 500 Hz. 630 Hz here, 26%, 630. It's 500 Hz and 630 Hz in most of them. 31, 630, 630, 75, and 100% 500 Hz. Let's listen to some signal recordings. If I didn't enable AGC, automatic gain control, you wouldn't be able to listen to this. This was loud. Power consumption. I use PowerNetics version 2. Idle, 10 watt only. Very low. Look, the NVIDIA, it's notably higher. 16 watt, it's 6 watt more. It's higher, notably higher. With two monitors, look at the difference. The 5070 almost double the power consumption with two monitors. Multimedia. Okay, the 5070 is 2 watt lower here, so better. Gaming, power consumption. The 5070 full HD, it's notably lower. 218 watt versus 247 watt. And with RTX on, it's 252 watt. On QHD, the RTX 5070 is 231.5 watt. 250 watt for the 9070, 251 actually. 20 watt difference, it's not that much. 4K, 251 watt again. And where is the 5070? Yeah, the 5070 is exactly the same, guys. 251 watt. So guess which is the most efficient from these two? The 9070, of course. Peak power consumption, HD, QHD, and 4K. 3D Max Speedway, average, and peak. Fairmark, 250 watt again, almost identical to the RTX 5070, the power consumption in Fairmark. Radeon, in Radeon, yeah, it requires lots of power, but it is not as fast as the 5070. In Radeon, NVIDIA has the edge. Power consumption peak about 35 watt above the RTX 5070. Overclocking, that's the interesting part. So the first thing you have to do is to drop voltage offset. In my card, I was at minus 170 millivolt, guys. Then I increased maximum frequency to 180 megahertz. And I increased the power limit to plus 10%. When you decrease the voltage, the V-core, the GPU's V-core, and you increase at the same time, you boost the clocks and you increase the power limit, it has huge potential. The GPU gets free, and let's look here. The maximum core clock. 3178 megahertz. Guys, this is a huge jump from the 2543 megahertz of stock. Huge jump. RAM can also be overclocked easily. Operating temperatures, not a significant difference here because you drop the V-core very low. And the hotspot. Power consumption is not increased notably, basically 10%, which I allowed, and the peak power consumption. And the overclock gain, stock in 3D Max Speedway, 57.55 FPS, overclocked 64.29 FPS. Guys, this is a difference of 11.71%. This is a high overclock gain. Only the RTX 5070 achieves a higher overclock gain. Cooling performance at 30 decibels running Fairmark, the lowest normal temperature, and the hotspot temperature is also pretty low. At 35, again the lowest, along with the RX 7900 GRE, and the hotspot also is very low. Clocks, 30 decibels, core clocks, okay, not that high, but it isn't terribly low either. In general, the ASRock RX 9070 has a good cooling system. Finally, epilogue. I have to admit, I didn't like at all the RTX 5070. For me, it is just an RTX 4070 Super with 30 watt higher power consumption, so it's not that good. The only thing on this card that makes it a little better than the 4070 Super is MFG, multi-frame generation. But if you decide to utilize MFG, if you don't want to use MFG, then there is no point in paying to get an RTX 5070. Only if somebody gives away this card to you. Now, 9070 versus RTX 5070, guys, there is no comparison. The numbers speak here. The average boost is 7.9% in frames, and in frames per watt, the improvement is 2.5 almost percent difference. So, not only the 9070 is faster, notably faster than the 5070, it is also more efficient. And it has 16 gigabytes of video RAM, so it's future proof, and even some current game titles require more than 12 gigabytes of video RAM to be smooth. Okay. The only thing that troubles me is AI, as you can see here in Procyon text generation benchmark, how far behind the 9070 is compared to the 5070. NVIDIA still has an edge on AI and DLSS, of course. And the pros, notably faster than the 5070, vastly improved ray tracing, guys, over Radeon A3. Highly efficient, 16GB video RAM makes you future-proof, FSR 4, low idle power consumption, especially with two monitors connected, much lower power consumption than NVIDIA's 5070. Fan stop feature, okay, HDMI 2.1b and DisplayPort 2.1a. PCI Express 5 support doesn't make a sense now because these GPUs are not powerful enough to fully utilize even the PCI Express 4 bus, but okay, it's a new technology, time to move on, okay. Hardware encoding improved, high overclocking potential in the 9070, and in this specific model, silent operation. Now, the problems. Prices are not even close to MSRP. You will probably have trouble finding a 9070 or a 9070 XT. I managed to score a 9070 XT from Amazon. They sent it to me. I have to check it on video to see if it is a real one or just a brick or something else. Given my experience with an AMD processor that I have to be very, very careful with Amazon. NVIDIA, ray tracing and AI technologies remain at the top. AMD still tries to follow. And some rendering apps, Blender, for example, don't work because of CUDA's absence. CUDA is powerful, is used by many, many apps. So, guys, yeah, AMD has to do something about that there. This was my review of the 9070 ASRock Steel Legend model. Guys, you can read the full review on hwbusters.com. I busted my ass to finish this review. It is a huge review, hundreds of charts, and please subscribe to our channel. You will help us a lot, you will make us stronger, and we will be able to have more samples and do more reviews to show you more stuff. That's all. Thank you. Bye bye, guys.